our group chose is about potassium fertilizer. It is a peer-reviewed article and it is produced by the government of Alberta. So I'm Ian. I'm going to be doing the introduction and determining potassium fertilization need. Lloyd will be doing soil potassium and the conclusion. Amanda will be doing potassium deficiency and crop potassium requirements. Lane will be doing choosing application rates, and Claire will be doing methods of application. So a little bit about potassium. Potassium is required by all life on our planet. Alberta has generally good soil potassium levels. Around 85% of our soils have adequate amounts of potassium, and about 15% have slightly to moderately low levels of potassium and require fertilization. Adequate amounts of potassium can dramatically improve plant growth, crop yields, and plant health. Straw, when grown with additional amounts of potassium, can grow stronger and it'll grow higher as well. All right, so some things you're going to learn from our presentation: how to tell if crop potassium is deficient, how to test for soil potassium, and how to apply potassium as a fertilizer, how plants are going to be uptaking potassium, and why potassium is important to both plants and animals.
My name is Lloyd Libbert, and I'll be covering the soil potassium portion of this presentation. Within soil potassium, the majority of Alberta has sufficient plant available potassium, but only 1 to 2% of all available potassium is actually available to plants. Alberta's main reason it has so much potassium is because its parent material has quite a lot of potassium in it. So there's 3 different pools for potassium. There's the unavailable potassium, slowly available potassium, and available and exchangeable potassium. The first is the unavailable potassium. This is 90 to 95% of total potassium. It is locked within the structure of the clay sheets and is completely unavailable for plants. The second pool is the slowly available potassium, which is 5 to 10% of total potassium. This is done through the weathering of clay, which slowly releases potassium. This kind of potassium slowly recharges the available potassium pool, and it is kept in equilibrium. This is the most important potassium pool and is the available and exchangeable potassium. This is only 1 to 2%, and it is dissolved in soil water. This is known as exchangeable, and they are loosely absorbed to the outside of clay particles because they're cations and they attach the anions on the negative surface of the clay. And these are easily taken up by the root hairs as shown by the diagram to the left here. So some more about the available potassium. As I said before, potassium only occurs as positive potassium ions, therefore it has to be adsorbed to something such as clay particles. Potassium is also fairly immobile in soil and does not tend to leach or move downward whatsoever. Within the field of agriculture here, soil potassium is mostly sold as KCl, which contains 60% of potassium oxide. The biggest source of KCl comes from muriate of potash, which is mined in Saskatchewan. It is a non-renewable resource as it's mined, so that's also a problem. To convert between potassium oxide to K ions is you have to divide by 1.6. And forage crops such as silage, potatoes, sugar beets, they have the highest K requirement and therefore have the greatest likelihood of having potassium deficiencies.
My name is Amanda Liebe, and I'll be doing the potassium deficiency part of this presentation. So when plants have a potassium deficiency, they can develop something called chlorosis. And chlorosis is the yellowing of the bottom older parts of the plant nearest the roots. In cereal grains, potassium deficiency appears as a burning or scorching of the older plant parts. In plants like alfalfa, it appears as white or yellow spots on the lower leaves. Chlorosis can also be from poor drainage, damaged roots, high alkalinity, which is high levels of bicarbonates and carbonates, or a nutrient deficiency. So in order to confirm that it is a potassium deficiency, soil tests need to be done. In this slide, it gives you more of an idea of what potassium deficiency looks like on a leaf. The yellowing starts at the leaf tips and then it continues down the leaf margins. It can also appear as yellow or white spots or scorched and eventually turning a brownish color. Potassium deficient soils are less common in Alberta compared to nitrogen, phosphorus, and sulfur. This picture here shows the soil areas of Alberta that are more prone to having a potassium deficiency. The shaded black area on the map shows soils that may be deficient, and this usually means that they are sandier soils. And the unshaded area of the soils map are ones that are not likely to be potassium deficient. There's a few main reasons for why it's uncommon here. And that's because the parent geologic material on which the soil developed contains considerable potassium-bearing clay minerals. Alberta soils are considered young and have undergone minimal weathering and leaching. And lastly, the crop removal has been minor, where cereals, oilseeds, and pulse crops, which are like beans and lentils and peas, have been minor, where have been the dominant crops. And this is especially where straw is left on the field after harvest, because 80% of the potassium taken up by crops remains in the soil and then is returned back into the soil. An increase in risk of potassium deficiency comes when you grow plants like forage crops, which are plants consumed by livestock, silage crops, which are like corn, legumes, and grasses, and can also be used for livestock, as well as potatoes and sugar beets, which have a high potassium requirement and take up and remove relatively large amounts of potassium from the soil. It is a relatively inexpensive nutrient, and the deficiencies can be corrected fairly easily with moderate rates of application. The most common used fertilizer is potash, which contains 60% potassium oxide. Here in table 1, it shows commonly grown crops and the nutrient uptake from the above ground portion of the soil. And you can see the big difference in the distribution of potassium compared to phosphorus and nitrogen, both in the grain and the straw. Potassium is significantly lower in the grains, but a lot higher in the straw. So after a harvest, the leftover straw, when put back into the ground, brings back the needed potassium for the next grow. Crop potassium requirements. So it's useful to know the uptake of plants, but this doesn't help determining how much fertilizer you need. In Alberta and most prairie region soils contain high levels of plant available potassium, and soils can usually supply adequate amounts for even high use crops for a few years.
Determining potassium fertilizer requirements. All right, so testing for the amount of fertilizer relates to the amount of ammonium acetate that has been extracted. So here in Alberta, we use the Kelowna method. It's the most common method for testing for soil potassium. The Kelowna method uses an aqueous solution of ammonium fluoride, ammonium acetate, and acetic acid for its testing results. All right, so an example of potassium requirements for barley. So the largest crop yields for barley were in soils that had less than 151 pounds per acre of extractable potassium. On fields with 200 to 250 pounds per acre, they responded moderately with about 15 to 30 pounds per acre of potassium oxide. Fertilizing anything above 250 has a low success rate. However, a maintenance application could be applied and it could help to replace the potassium taken up by the crop. All right, so there's a broad spectrum of results between Canada and the US when it comes to adding potassium as a fertilizer to the crop. The US says the presence of chloride in a potassium chloride fertilizer has increased crop yields, and it has also helped suppress plant diseases and weeds. But we haven't, here in Alberta, we haven't gotten those same responses. So if we did use potassium chloride fertilizer, it would have to be on a trial basis. Soil deficiency may also happen on high test soils because of low potassium diffusion on the cold, dense soil. Slow diffusion can be used to early seed crops in northern and central Alberta.
So my name is Lane and I'm doing choosing application rates. So choosing an application rate for potassium fertilizer is dependent on multiple things. First, choosing an application rate relies on soil test levels to determine how deficient in potassium a soil actually is. Furthermore, the type of soil and the type of crop being planted affects the rate of fertilizer application. It's important to note this is also dependent on the responsiveness of the crop. Next slide. So this is an application rate for cereal crops in this table here. For example, this cereal crop planted on a brown soil that is very deficient in potassium, about 0 to 50 pounds per acre, would require about 80 to 100 pounds per acre of K2O fertilizer, while the same crop planted on, say, a dark brown soil that is only moderately deficient in potassium would require 25 to 45 pounds per acre of K2O fertilizer. And so the type of crop present on the field really determines how much fertilizer is going to be applied to the field. So next slide. These are some application rates for oilseed crops like canola, mustard seed, and various other types of crops. So what's interesting here is at the bottom it says rates above 15 pounds per acre for small seeded crops should be banded or broadcast to avoid seedling injury. And you can go to the next one now. This is an application rate for pulse crops. We can see just from the numbers here that it's starting to vary greatly, especially once you start getting into the moderately deficient range. You see a lot of variation between the pounds per acre of fertilizer you need to apply. It's also interesting here, rates above 20 to 25 pounds this time for pulse crops should be banded or broadcast to avoid seedling injury. Next slide. These are some application rates for alfalfa. Again, the numbers varying greatly, especially once you get into the adequate range. You can see there's not even any fertilizer needed for this type of crop. Next one. So these are application rates for some grass crops. And this is interesting because this kind of ties into what Ian was saying. Fertilizing barley, which is a grass crop, after anything above 250 pounds per acre has low succession rate. So just from the table here, you can see that once you get to about the 250 mark, it's recommended just no potassium fertilizer application is needed for this crop. Next one. These are some application rates for root crops, such as potatoes, sugar beets, like they have in Tabor. These greatly changed now with the table. So once you start getting into the moderately deficient range, you can see there's a lot of variation between the numbers from this crop and other crops. Next slide. So in Alberta, the majority of soils are only slightly to moderately deficient in potassium. With these soils, the recommended application rate is about 15 to 30 pounds per acre of K2O on cereal crops. This ensures a maximum response to the fertilizer application. On soils that are very deficient in potassium, about 150 pounds per acre, higher rates of potassium fertilizer ensures maximum response and productivity. Furthermore, on soils that are very deficient in potassium, an initial application of 200 to 300 pounds per acre can be used, followed by a much smaller application of about 30 pounds per acre the following years. This just ensures a residual buildup of soil potassium levels over time. You can go to the next slide. Research in Alberta has shown that soil tests are not very reliable on soils that have had high rates of fertilizers added. This is because soil tests do not adequately reflect the residual fertilizer in the soil. So for example, a soil test was conducted on a very deficient soil that had 810 pounds per acre of K2O applied to it. And the soil test for this potassium, for the potassium in the soil, was still reading deficient. But the crops were still doing well. They were still growing and they were still responding to the potassium. The explanation for this is that the heavily fertilized soil contains residual crop available potassium that doesn't get picked up in the soil test. This means that potassium deficient soils, which have been treated with high rates of fertilizer, any additional fertilizer for the following years should only be considered based on crop response and production rather than a soil test.
Potassium fertilizer. Hi, I'm Claire. I'll be talking about potassium fertilizer application methods. Why is application methods important? Potassium is not mobile in the soil, so it's important how and where it's applied to get the best results. Too much fertilizer can have a negative effect on the germinating seeds. So potassium chloride is a salt and a very common fertilizer. And it can cause the salt effect, which limits the amount of moisture that the germinating seeds can uptake from the soil. And this can reduce or delay germination or even kill that plant. Soil types also play a factor in this. So clays and soils with higher organic matter can retain higher amounts of moisture, and this can help in reducing the amount of salt effect on those plants. And then as well, each crop is unique. So there's canola fields, which are small seeded, smaller seeded crops, and they can't tolerate fertilizer as well as, let's say, cereal crops. So one example or one method of application is a seed drill. It's quite efficient with how much fertilizer is used. So the way it works is when the seed is getting planted and put in the ground, fertilizer is put directly in with it. And this can obviously be helpful because potassium is immobile in the soil. However, if you use too much, it's directly in contact with that seed. So it can have the salt effect, which is quite negative. So you have to be careful with the amount that you put in the soil when you use this method. And then there's side band. And you can kind of see how that works down in the image off in the corner. So the fertilizer is put roughly an inch below the seed as well as an inch off to the side. This varies depending on seed and crop, of course. And then, and this gives you a little bit more leeway. You can add more fertilizer with this method because the fertilizer is not in direct contact with the seed. It adds more of a general fertilization to the soil than directly to the plant, but it's still within the limits of the plant and can move to help fertilize it. Banding. Banding similar to side banding. And as you can see in this picture as well, it's slightly different. So concentrated bands of fertilizer are put in furrows, and beside that was where in a separate furrow the seed would go. And so they're not in contact again. They're separated, but it's just a different method, but you would get similar results from side banding and banding. Broadcasting. Broadcasting is not as recommended for annual crops and crops that are doing quite well or soils that are quite efficient in potassium. However, if it is a seriously depleted soil, then you can get a lot of fertilization and cover a lot of ground this way. As well as it's the application method used for perennial plants. So they spray the plants and it's easier to apply to already existing plants. And this is all climate and the environment also plays a role in when you should broadcast. So for drier climates, it's recommended that you would fertilize in the fall and then have the snow melt and have the fertilizer go into the soil that way to prepare it for spring planting.
Thank you for listening to our presentation here, and I just wrap up pretty quick here. So we'll just go over what we talked about basically. So with Ian, we sort of talked about the determination of potassium fertilizer need and how the Kelowna test works. Myself, I talked about soil potassium and the three different pools of potassium: the unavailable, the slowly available, and the available. Which available is the most important. We had Amanda, which talked about potassium deficiency, as well as crop potassium requirements. Then we had Lane, who talked about mostly just the application rates relating to some specific crops, and then Claire with the methods of application. Thank you very much.